Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to discuss an example on the mesh analysis for AC circuit. If you look back at the previous video, there's some steps on how to search or how to solve a mesh analysis problem. So the steps are, for the first step, we need to prepare the circuit in phasor form. So if you look at the example here, and we look at the these things, the sources, they are in phasor form. And if we go to steps number 2, all the passive elements here, the capacitor, inductor, and the resistor, are all in impedance. How do you know? It's just by looking at the unit of this impedance. Like capacitor here, they have negative J2 ohms. And then we go to step number 3. Number 3, we need to identify all the loops or the imaginary mesh. So we need to draw the mesh. Okay. This one up to you to go for counterclockwise or clockwise direction, but you need to name all the current. So if let's say here is I1, if you realize I'm using capital letter with bar, so this is I1 and then I2 with bar and I3. Okay. And then you need to set the value for this imaginary current if it is exists. So if you look at the current source here, this part, the current source is at the outer loops. So we see this as a I1 equal to 2 with 0 degree. Okay. And then what about I2 and I3? There's no current source at the outer loops, so we cannot simply identify the current source value. Then we need to proceed with step number 4. What is step number 4? You need to identify which one, or is there any supermesh exists in the circuit. Since here, what is a supermesh? Supermesh is when you have a current source in between two loops. This current source can be an independent source or dependent source. As long as this is in between two loops, two closed loops, then you need to draw the boundary around these outer loops. And if you have a current source in series with some element, you need to include that as part of your supermesh. And if there exists supermesh, then you need to build up two equations. What is these two equations? One is for KVL around the outer loops, and then second is a KCL at the current source. All right. And then step number 5 is to build up KVL around the loops there is with unknown mesh or unknown current there. So here we need to build up KVL around this loop number I2, and KVL around loop number I3. Okay, and then the final steps is to find value of interest. Okay, all right. KVL around loop number 2. So we start from 8 ohms. If you look at the current direction of I2 is counterclockwise, and the direction is going into 8 ohms. 8 ohms. So if you look here, since 8 ohms is a passive element, you will have a positive. And then we just write down the equation. 8 ohms shares with the current I2 loops. since the value of interest is the V here, so you need a voltage is equal to IR. The R is the 8 ohms and I is I2, and then you need to flow, the current will be flowing into J4. Since J4 here is sharing between I2 and I3, then you need to have the current is entering a passive element should have a plus here and minus when it is leaving. So over here we have a plus J4 into the current of what we focus first. So here is I2 minus with the J4 shares the other loops. So you have a minus 3, minus 3. And then you need to plus. Why plus? Because current is entering minus J2. So you will have a plus here. Okay, a plus here. So here we have a plus and then minus J2 of I2. And since the loop is closed, then it is equal to 0. And then what you need to do is rearrange this, and then you get some equation for loop 2. Before we proceed with the value of interest, we need to figure out what is our aim. Our aim is to find I naught. I naught is equal to the loops of I2. Over here you need to observe the current direction of the I2. If this is the same with I naught, then it is equal to each other. Next, KVL around loop 2. If you start from the voltage source 10 30 degree, the current is entering a negative side. So you start with that. This is negative 10 30 degree, and then we go to 6 here. Current is entering a passive element, should have a plus. Then this is plus 6 into since we focus for the loop 3 here, then we have a I3 minus with 6. The 6 ohm is sharing with in between I1 and I3, so we minus with the opposite loops, I3 minus I1, and then we have a plus J4. How do you know this is a plus? You can check on the current. Current is entering a J4 here. You follow the current direction of your counterclockwise I3 imaginary current. So since a J4 is a passive element, then you should have a plus here, and leaving current is a minus. So you follow the plus there, then you get the plus J4, and then into what? Into the I3 minus with the opposite current I2, and then equal to 0. Since I1 is equal to 0 degree here, then we can substitute into the equation over there, and then rearrange this, and then you will get the answer. We can solve this using Cramer's rule, or you just rearrange the first equation here, and if you rearrange this, I2 is equal to J4 divided by 8 minus J2, or I2 equal to J4 I3 bar divided by 8 minus J2, and substitute this thing, then you will get Substitute equation number 1 into 2, you will get 6 plus G4 into I3 minus G4. I2 is equal to G4 divided by 8 minus G2 into I3 power. And then if you see here, we have only one unknown, which is the I3 of both sides, right? So solve this. I3 will be equal to 2.42 minus G 0.449 or 2.461 with minus 10 with 0.516 degree. And what about I2? You just substitute I3 into equation number 1 here, and then you will get I2 is equal to 1.194 65.45 degree. Okay, and I2 is equal to I naught. Coming from where? Coming from this equation, because this is our aim. Okay, with that, I think, yeah, you need to use your calculator. Make sure you set it using complex form and also in degree. Okay, with that, thank you. Assalamualaikum warahmatullahi wabarakatuh.